Okay, picking up where we left off, we ended up with finding this equation. And what we're going to call this is, we're going to call this the derivative. This is the derivative of the cubic equation that we had been working with. Also known as, AKA, I call it the slope formula. It's the equation that allows us to find the slope of the cubic graph at any x value. So this is the generic function. Do we have to do everything that we just did? Do we have to specifically find the tangent slope at x equals 1 and use that like we did in our first example and then go through and find the derivative? No, we don't have to do all that. So if I'm asked to find the slope of the curve at a particular x value, I probably am going to use this last method of finding the derivative and then proceeding with the following steps. So let me just kind of verify with you real quick that this formula does indeed give us the slopes that we found previous. So in our first example, we found that the slope of the graph, the cubic graph, was -3 at 1. So let's use this equation. If I were to evaluate this equation at 1, notice I do get -3. Okay, using the same derivative, again, I'm just going to rewrite it here. Let's verify that the slope of the curve at x equals 2 is 6, like we found in the previous example. So everywhere I see x, I'm going to replace it with 2. Notice once you perform the calculations, okay, you do get 6. So hopefully you see through us using this derivative that we have verified that this is indeed a good way, a correct way to find the slope of the curve at any x value. So that's kind of where I wanted to get with you guys, and I'm hoping that I also did mention earlier that really one of the main things that we like to do is write equations of tangent lines to the curve at a particular x value. So perhaps using this notation right here to help us write the equation of the tangent line at x equals 2, I'm going to do that here. Okay, so using point slope, we need the point on the graph, and we need the slope of the graph at that point. Well, we found that previous up here to be 6, and then we know the point 21 is on the graph. Okay, so we've got y plus 1 and 6 times quantity x minus 2. You could distribute and clean it up if you want and get 6x minus 13, but there's really no need unless there's something else that you needed that equation for and you needed to do those calculations. So at this point, this is a great equation of the tangent line to the curve at x equals 2. Okay, so we've accomplished our objective. So tomorrow we're just going to practice finding derivatives of different equations that are going to be given to us so that we can then use those derivatives or slope formulas to find rates of change of the graphs at particular x values. So I'll see you then.